Every day we say that there is no time. Time passes very quickly. Time is money. But have you ever seriously thought about it? This is the time we are hanging in our mouths. What exactly is something? Is it visible and touchable? It really exists objectively like air. Or say it. It's just an illusion in our brains. 4th century AD. The Roman theologian Saint Augustine. I said something especially interesting. He said what time is. If no one asks me, I am very clear about it. If someone wants me to explain, I am not clear about it. This story tells us time is very common and also very confusing. Humans live with time every day but always don't understand why does it exist. Have you ever thought about time? 2,000 years have passed. We have the ability to discover atom. And we know something about the general relativity theory. But if you asked me, what is time exactly? Maybe I still have to shake my head. Just like Augustine, you do the same thing. So today is the day. We start from the development of physics. Look at time. This problem has troubled mankind for thousands of years. Modern science. What kind of answers did he give? Let's start with one of the simplest questions. How did time come? Or to say, how do we know that time is passing? The answer is actually very simple. Because we see changes. Do you think about it? If everything in this world were static, nothing is moving, nothing is changing, can you still feel the existence of time? The sun always hangs in the same position on heaven. Your heartbeat always stops at the same stroke. The coffee in your hand is always at the same temperature. Under this extreme assumption, does the concept of time have any meaning? In science fiction films there are often such bridges. The protagonist presses a button. Time has stopped. Everyone stays still. The water drops hang in the midair unmoving. Birds stop in the air and do not fly. But you think trainfully about it. This time stops. What is the difference between stable and world state? If all things stopped movement and change, that time stopped and the world stood still. Essentially, it is one thing. So the first essential characteristic of time. It floats out of the water surface. Time is the unit of measurement for change. The change of the day is completed in 1 month. Spring, summer, autumn, winter, 4 seasons changes completed 1 year. A person from birth to death. This change has been completed approximately 78 years ago. Without change, there is no time. That question came again. How do we measure these changes? This involves a core concept. Cyclical cycle. What was the first thing humans used to count time? It is the sun. The sun rises and falls around the time. This cyclical movement gives us the concept of heaven. Then there is the moon. Lunar round moon is missing. Week and week starts again. He gave us the concept of a moon. Then 4 seasons are replaced. It gave us the concept of our year. You find that you do not. All these timing methods, they all have a common characteristic. They are all cyclically repeated phenomena. Why must it be cyclical? I'll give you an example and then understand. Suppose there is a button. It happens every single time. It will change a color, but it changes the law of color completely randomly. Sometimes a second changes 3 times. Sometimes 3 minutes change once. The color of the transformation is also red, green, blue. There is no irregularity. Would you use this button to arrange a deal? You tell your friend that the button becomes green for a 3rd time when we eat. This is the 5th time it becomes green, or they will soon die of hunger. And still not green. Who has endured this? So we need something that can predict changes to serve as a timer. And cyclically repeating things. Nature is the best timer. But only by the sun and moon. The accuracy is very low. You tell when the sun reaches top of your head. Then we will meet. This error may be 1 or 2 hours. So humans began to invent a variety of timing tools. The solar orbit, sand leakage, water clock, mechanical clock. The atomic clock until today. Here is an especially interesting logical trap. Feynman spoke specifically in his physics lecture. How do we know that each day is equally long? You might say, you may be saying, because every day the clock goes 24 hours. So how do we know that the clock is running correctly? Because the clock's shock cycle is fixed. So how do we know if the shock cycle is fixed? Take a look at it. It's like a snake biting its own tail. Use your pulse to calibrate the clock. Use the clock to calibrate your pulse. Who is exactly right? Feynman's answer is, we can never measure time itself. What we measure is just various variables: the movement of the clock, the shock of the atom, the Earth's self-rotation. Then use one variable to compare it with another. Time is the absolute standard. In fact, it is what we assume. Legendary legends. Galileo in the Cathedral of Pisa. It produced a famous intuition. He observed a slowly swirling candle hanging lamp. But he didn't look at it. He counted his own heartbeat. He discovered that he found, regardless of the breadth in which lights are rolled, it is large or small, each time during the movement, his heart rate is the same. So he came to conclusions. The clock has the same length each time it moves. This story sounds very beautiful. But if you think trainfully, the problem will be found. How did Galileo know that every heartbeat he had was the same length? Years later, years after, doctors have started using clocks to measure a patient's pulse, or use a clock-style watch. Use pulse to determine whether the clock's swing is a rule. Also use the sitting clock to determine whether pulse beats are a rule. Isn't this a monster circle? This monstrous circle reveals a profound reason. We have never directly measured time. What we measure is only changes in various physical quantities. Then use one change to calibrate another changes. Time itself is always hidden behind all measurements, like a ghost that can never be directly observed. This view is actually very profound. It tells us about it. Time is not a physical quantity that can be directly measured. It is more like a reference system that we invented to describe change. Like a coordinate system is not space itself. Instead, we describe space as a tool. Time is not a change in itself. Instead, we describe the tools of change. Well, now we know the nature of measuring time. But this awareness still stays on the level of how to use time. Not yet touch time itself. What this core question is. To answer this question, we must be driven to deep water. The first person to give a clear definition in time, it is Newton. Before Newton, people's understanding of time, it still stays in the time of Aristotle. Aristotle thinks that the time dimension and the spatial dimensions do not interfere with each other, and the laws of motion in heaven and on earth are different. The stars in the sky make perfect circular movements. Earth-based objects tend to return their natural position, heavy stuff downwards, light objects float upwards. This theory has ruled Western academic community for almost 2,000 years. Newton published in 1687 the mathematical principles of natural philosophy. He proposed a revolutionary concept, absolute time and absolutely space. Newton said, time itself is flowing. Due to its nature, it flows evenly. It has nothing to do with any external things. Translating adult languages, time is like an eternally flowing river. No matter what happens in the universe, whether you are on Earth or in Mars, whether you are a static or movement, time passes at the same speed. This concept sounds very well in line with our intuition. Isn't that how we feel? Time is fair for everyone. One day, 24 hours. No one is too many. None of them are too few. If you are poor, well, wealth is good as well. Run fast or well, slowly or well. Time is a companion to you all. Newton's concept of absolute time, in accordance with his three major laws of movement and all the laws of gravity, build a perfect mechanical system. This system has been too successful. He explained the causes of tides. That's the gravitational force of a moon that is striking. He predicted the return of Halley Comet. The comet appeared in 1758. He also helped astronomers discover Neptune. People first predicted its location by calculation. Then it was found in the telescope. Classical mechanics achieved unprecedented success. Newton's time view has also become a gold law in the world of physics. Over the next 200 years, almost no one has questioned the concept of absolute time. Until the end of 19th century, physicists began to study electromagnetics when they started. Trouble has come. Maxwell established the electromagnetic equation group in 1865. This equation sets beautiful people suffocating. It unifies electrical and magnetic. He predicted the existence of electromagnetic waves. It also gives the precise value of light speed. But this equation group has a headache nature. It does not meet Galileo's principle of relativity. What is Galileo's principle of relativity? Simply put, simply speaking, the laws of physics should be the same in all invasive reference systems. You do an experiment on a stationary train, and to do experiments on a train of uniform speed movement, the obtained laws of physics should be the same. Newton's mechanics meets this principle, but the Maxwell equation group does not seem to be satisfied. According to the Maxwell equation group, the speed of light is a constant, approximately 300,000 kilometers per second. But according to Galileo's transformation, if you in the light run, light should be faster relative to your speed. If you run with light on your back, light should be slower relative to your speed. This creates a contradiction. Physicists have been suffering from this headache for decades. Some suggest that there may be a substance called etherium in the universe. Light is spread in etherium, just like sounds spread through the air. If etherium exists, then we can find an absolutely static reference system. The concept of absolute time can be preserved, but the 1887 Michelson-Morley experiment in 1887 gave etherium theory a blow to heart. This experiment attempts to measure the speed of Earth's movement relative with etherium. As a result, it was discovered, no matter how you test it, the speed of light is the same. Etherium does not seem to exist at all. Physics is in crisis. Newton's absolute time-space view and Maxwell's electromagnetism. It seems that only one can be retained. Right in this joint bone eye. A small employee working at the patent office stood out. This person is called Einstein. Einstein published his narrow relativity theory. The core of this theory is two principles. First, the first one. The speed of light remains unchanged in the vacuum. It has nothing to do with the motion state of a light source. The second is the second. The laws of physics are the same in all invasive reference systems. These two principles sound very strange, but their inferences subverted all human perceptions of time. Einstein discovered, if the speed of light does not change, then time cannot be absolute. Observers of two relative movements, they will be different about simultaneous judgment. You think two things happen at the same time. I feel like one first after another, and we are all right. This sounds too anti-intuitive. How can two people judge at the same time differently, and it's all right? Einstein gave a wonderful thought experiment. Imagine a train traveling on high speed. There is a light source in the middle of this train. At the same time, two beams of light are emitted to both head and tail, or observers standing on the train. These two beams of light simultaneously reach the head and tail. Because the chariot head and tail to light source distance is equal, the speed of light is the same, but for observers standing on the ground, the situation is different. The train is moving forward. The train's tail is running towards the light. The train head on the back of light running. Thus, the distance between light and tail is shorter. The distance to reach the train head is longer because the speed of light remains unchanged. Then light should first reach the train's tail. After arriving at the train head, the same incident. What people on the train see is simultaneously. What people on the ground see is different at various times. Whoever is right, all are correct. Because in this universe, there is no absolute at the same time. Simultaneous sex is relative. Even more surprising is the speed with which time passes. It will change with the speed of movement. The faster you run, the quicker, the more slowly your time flows. Atomic clock on GPS satellites. Every day is more than a clock on the ground. Slow about 7 microseconds. Because satellites are in high-speed movement. If this error is not corrected, GPS positioning accuracy, every day there will be a deviation of several kilometers. The navigation of the mobile phone you are currently using. Every moment Einstein's theory is verified. So when the next time navigation is correct, remember to thank you for this great man. The narrow relativity theory also gave a famous twin experiment. A pair of twins. Brother remains on Earth. Brother on a spacecraft to approach the speed of light for space travel. Until my brother comes back. He finds himself much younger than his brother. Because in high-speed movement, brother's time has passed more slowly than brother's. This is the reason why this young paradox was called. Because it sounds too ridiculous. But it is not a paradox. It is real. In 1915, Einstein has published the general relativity. Gravity is also included in this framework. He found that the gravitational field also affects time flow. In a strong gravitational field, time passes more slowly. This means that it is meant to mean if you are standing next to a black hole, your time will be much slower than the people on Earth. You stay in a black hole for one day. It may have been on Earth for several years. In the movie Star Trek, there is such an incident. The protagonist spent several hours on a planet near the black hole. Returning on board the spacecraft, he found that his companion was already 20 years old. The relativity theory crushed Newton's absolute time view. Time and space are no longer independent of each other. They are entangled together. It constitutes a four-dimensional time-space. Time will change with the speed of movement and gravitational intensity. It is no longer that evenly flowing river. Instead of one that can be distorted, it was stretched, compressed rubber muscles. But the revolution of time brought about by relativity, it's only half the story. Because relativity theory, although it tells us time can change fast, slow, but it does not answer a more fundamental question. Why time can only go forward and cannot go backwards. Do you think about it? The space can be forward or backward. You can go up or down. But time can only move from the past to future. I have never seen anyone from the future back to the past. A broken glass will not restore itself. The water spilled out will not recover itself. People who get old do not become young by themselves. Why does time have such a special arrow? The answer to this question is hidden in another branch of physics. This branch is thermodynamics. The second law of thermodynamics tells us, in an isolated system, the entropy always increases, or at least remain unchanged. It will never spontaneously decrease, the so-called entropy. Simply speak, entropy is a measure of the degree to which chaos occurs. A room, you don't clean it. It will only become increasingly messy. It will not become clean on its own. A cup of hot water, put it on the table. It will only slowly become cold. It will not heat itself. This is the increase in injuries. Boltzmann in the late 19th century gave a statistical explanation of the entropy. He said, in fact, entropy is a probability issue. Throw a pair of clean poker trains into the air. It falls when it drops. It is almost impossible to still be in order because there is only one state of order, and the state of chaos has countless kinds. The system moves spontaneously from order to disorder. Not because orderly state is forbidden. It is due to the probability of a disordered state. Too big, too much. You can understand this way. Suppose you have a box. The intermediate dashboard is divided into two halves. On the left is a gas molecule. On the right is vacuum. When you remove the separator plate, gas molecules will spread throughout the box. This process is spontaneous. No external force is needed. But you've seen gas molecules spontaneously gathering to one side of the box? In theory, it is not impossible, but the probability is so small that it can be ignored. If there are only two molecules in the box, sometimes they run to one side at the same time. But if there are 100 billion billions of molecules in the box, at the same time they run to one side of probability. Even less than you bet 100 million words in a row at the lottery. Boltzmann's discovery gave time an arrow. The direction of entropy increases the orientation that time flows. You broke the eggs. The eggshell fragments will not go back together on their own. You spray perfume into the air. The perfume molecules will not gather themselves back into the bottle. These irreversible processes define the direction of time. Boltzmann's discovery is too important, but he also made him pay a painful price. The mainstream physics community at that time did not accept atomic theory. Boltzmann's theory is considered to be a heretical cult. The famous physicist Mach is a firm opponent of atomism. He believes that atoms are merely a mathematically convenient assumption. It is not something that really exists. Boltzmann and Mach, among others, had long-term arguments. But it is always impossible to convince the opponent. During continued attacks and questions, Boltzmann's mental state is getting worse. In 1906, during his vacation in Trieste, Italy, with a rope he ended his own life. On his graveyard he trained only one formula. S is equal to KLNW. This is the famous Boltzmann merchant formula. K is the Boltzmann constant. W is the number of microstates in a system. Today is today's day. This formula is engraved in countless physics textbooks and those who once attacked him. It has long been swept into the garbage dump by history. Commercial increase theory tells us the direction of time is determined by probability. Time can only go forward, because the probability of moving forward is too much bigger than going backwards. This is not the prohibition of natural laws. It is just the necessity of statistical laws. But the story is not finished here, because thermodynamics gives the time arrow. With quantum mechanics and relativity, the concept of time, there is a profound contradiction. In the equations of quantum mechanics, time is reversible. He determined the direction, the Dirac direction. These describe the equations of microparticle movement. All can remain unchanged during the reproduction of time. In other words, in the case of at the microscopic level, past and future are symmetrical. There is no direction more special. An electron moves from A to B. You put the time down here, it returns from B to A. It is also in accordance with the laws of physics in relativity theory. Time, though it can change quickly, slowly, but the basic causal structure is preserved. You cannot go back to the past through exercise. Go kill your grandfather. It is impossible to make a time paradox. Relativity theory time, although soft, but not entirely arbitrary. But in thermodynamics, time has a clear arrow. The past and the future are very different. These three theories are a cornerstone of modern physics, but they struggle with each other about the description of time. This contradiction has troubled physicists for a century. More troubling is the fact that when we tried to combine quantum mechanics and general relativity theory, building a quantum gravitational theory, the concept of time simply restored the disappearance. In quantum gravity theory, there is a famous Willard-White equation. This equation describes the evolution of quantum gravity systems, but you cross the entire route. You cannot find a time variable. Time in this theory does not exist at all. What does this mean? It means that it is meant to mean when we go deeper into the most basic physical levels, when we try to describe the universe in our most basic language. The concept of time may be superfluous. It is not the original attribute of universe. Instead, it emerges from something more basic. This sounds so crazy, but there is an analogy that may help you understand. The so-called temperature is the average motion force of molecular movement, but at the individual molecular level, you cannot talk about temperature, because temperature is a statistical concept. It is a manifestation of the collective behavior in large numbers. You can say that a glass of water temperature is 50 degrees, but you cannot say that the temperature of a water molecule is 50 degrees, because a single molecule has no temperature, this property. Time may be the same as time. At the basic physical level, there is no time. Only when we put together a large number of basic processes, time only emerged as a statistical concept. Just like humidity is not a water molecule property, but when a large number of hydrogen molecules are gathered together, like the attributes that appear. This view is called time emerging theory. He believes that he thinks time is not a basic component of the universe. Time is an emerging attribute of a complex system, if this view is correct. So we ask if time exists? It is like asking if humidity exists. The answer is to exist at some level. There is no existence at some level. It depends on what scale you use to observe. So around such a large circle, what is the essence of time? Exploring physics for hundreds of years. Maybe we could scatter such a picture. First of all, the measurement level. We use cyclical changes to define time. Use various timers to quantify time. Second is the color of atomic moon movement 91,92631,770 times time. A year is the time that Earth rotates around its sun a circle. It is said to be blank. Time is a language invented by humans to describe change. Again, the physical level. In relativity theory, time is intertwined with space. It is a four-dimensional time-space. Time can change fast-slow. It can be distorted by gravity, but it always retains the cause and effect structure. You cannot go back to the past and kill your grandfather. Do not think about it anymore. Grandfather's paradox in relativity theory is poisoned and dead. Then there is the statistical level. The direction of growth defines the arrow in time. Make the past and future different. This arrow does not come from the basic laws of physics. It is based on probability and statistics. Time forward, purely because the probability of moving forward is too big for it to be so great. It is almost impossible not to move forward. Finally, the cognitive level. We use time to organize memories, planning for the future, understand the cause and effect. There is no time for this concept. Our consciousness cannot function. Do you think about if there were no yesterday, today, tomorrow, these concepts? You can't even ask me what I am going to do tomorrow. So does time exist? If you ask, time is not an objectively existing entity like stone, water, air. The answer may be negative. Time is not a matter. Nor is it an energy. It is more like a relationship, a type of structure, an emerging attribute. You cannot put time in a bottle. Nor can the weight of time be measured by a sky level. But if you ask what is, time is not a truly effective concept of time. The answer is affirmative. Time, though not a basic entity, but it is an indispensable tool to describe our universe. There is no time. Physics cannot be established. There is no time. Cause cannot be defined. There is no time. Civilization cannot be passed on. In three subjects there are words speaking especially well. Give time to life, instead of giving life by time. Time itself may only be a concept, a framework, but everything we experience in time, our memories are our memory, our emotions are our feelings, our growth. But it is really real. Time may not be the most basic thing in a universe, but it is we who understand the universe. Understand your own most important key. It is the trace of change that leaves. It is a causal bond woven by cause and effect. It is the life measurement of its own mark. Therefore, there is no existence of time with its intersection. Rather than think about how to use the time in our hands well. After all, after everything, no matter what the nature of time is, the time we all have is limited. With limited time, do something meaningful. Love someone who deserves to be loved. Explore this magical universe. This may be the time to give us our best gift. How long have you not looked up to the stars? For the first time since ancient times, humans have looked at a starry sky. Take a telescope to Galileo. Once again, humans will step on the moon. This exploration history spans thousands of years. Everything is written in this book for the star space history of spectators. This is not just an astronomical copbook. Moreover, how a human being gradually understood the universe. Know your own epic poem, from myth to science, from the horizon to deep space. Each page makes you think again. Who are we, what is our position in the universe? Written to everyone who has ever looked at the starry sky. When giving starry sky to the spectator, put the stars and sea in your bookshelf. Click on the link below. Start your own space journey.